Lecture 19A, the fourth example, Killing equation. Now we will apply to spherical coordinates. So in this case, what you want is to solve the differential equation to obtain the killing vector. Now I'm imposing the equation, killing equation to be 0 and find u, okay, which is the killing vector. Now you use a spherical coordinate in which the radius will be 1. So my focus is only the surface of the sphere. So let r, theta, phi, where r is equal to 1, be coordinates on a sphere S2 with this angle here is a polar angle, a theta between 0 and pi, and this is azimuthal angle and phi between 0 and 2 pi. The metric is, you see, ds squared, d theta squared plus sine squared theta d phi squared. So you go in the part, I think, the part A, part 1, you see the spherical coordinates in which I will obtain all this relation over here. So the metric components are g theta theta is equal to 1, g phi phi is sine square of theta, and g, attention, this is symmetric, theta phi phi theta is equal to 0. Since the coordinates, you see the system, the coordinate system, they are orthogonal, okay, or orthonormal. Now, the goal, find the vector field u expressed by its components. You see, attention, u theta, u phi are the contravariant components because the basis belongs to this case, the basis is the covariant basis vectors. Satisfy the killing vector equation. This I'm imposing, you see, and find out u. This is different from the previous examples, okay, in which we want to verify. Here, no, I want to find the killing vector. So, also you compute Christoffel symbols of S2. You see gamma, phi, theta, it's minus sine theta, cosine theta. This is symmetric, you see. This is a torsion free. And I impose that, this cotangent of theta. This is non-vanished. Let's put here, non-vanished. No-vanished Christoffel symbols. Now, let's expand, step 2, let's expand the killing equation. This equation, attention, this here, we have 2 free indices, you see? So, in this case, I and j will be 1 and 2, you see? But they are free. So, and I want to apply this relation here, which is the killing vector expressed in covariant derivative, you see, as you did before. So there are 3 independent components. You see 1, 1, 1, 2, in this 1, 2 is equal to 1 because it's symmetric, and 2, 2. So I is equal to 1, I denote as theta, and I is equal to as phi. So this is 1, 1, you see? Then I substitute there, you write, you see the killing vector. I'm imposing this to be 0, you see? It must be 0 because I want to find, again, I'll repeat, I want to find the Killing vector u. I'm not verifying, see? So this equation over here, this is covariance of u theta, this is related to the partial derivative and the Christoffel symbols. Now, you see, this is vanished Christoffel symbols, which implies that partial of theta, u theta is equal 0. You just copy here and you conclude that u theta is constant in theta. You see? So u is, the components are u theta and u phi. So, but u theta is constant. That's equation 1. It's quite clear. So, I will, this item A, this item B. Now, this case corresponds to J is equal to, I is equal to, J is equal to. So I just substitute, you see, this case is 2, 2. You see, that's phi. Then I substitute over there. Now, you see this, that the covariant derivative of u phi is partial of phi u phi. Now, again, this is non-vanished Christoffel symbols. As you can see, I wrote this here. You see, this here. You see there. You see here. So I substitute this by minus sine theta cosine theta, and this is 0 because it's vanished Christoffel symbols. So this leads to this relation here. So it's equation 2. It's quite easy, just substitute and see it. Now the mixed term, I have I is equal 1, J is equal 2, or J is equal 2, I is equal 1, because it is symmetric. So the mixed term, you see here, you see I is equal 1, J is equal 2. J is equal 2, I is equal 1. Now I add, and this imposed to be 0. So this leads, I develop this. This is a Christoffel symbol, you see, and attention, you see here, you see K and K, okay? I have to add, you see, I have to add for I is equal 1 and I is equal 2. You see, look, I is equal 1, I is equal 2, because this K over here, this is dummy. You see, I just use this to write down, to expand right here, you see? So, again, this is non-vanished Christoffel symbols, minus sine theta cosine theta, as I wrote over here. You see? I see here and I substitute there. So, this term, this leads to the partial phi, u phi, sine theta cosine theta u phi is equal 0. This is equation 2. Now let's move to the mixed term. The mixed term, you see I is equal 1, J is equal 2. J, this case, J is equal 1, I is equal 2. This case, I is equal phi, correspond to phi, and J correspond to theta. So I just see it and substitute. I have two terms over here. You see the mixed term. I have this term and this term. This term over here, I wrote here, and I work on this. You see clear, this is a vanished Christoffel symbol. This is non-vanished Christoffel symbols, as I wrote over here. You see, you just copy from here to here. So then this term, you see, is the covariant derivative of u phi, this component, is just partial of theta u phi minus cotangent theta u phi. Now, I have to work on this term. I work on this term, now I work on that term. So I just substitute, you see, and see there that this is vanished, Christoffel symbols. And this expand, you see, in two terms, k is equal 1 and k is equal 2 over there. So this is non-zero, this is non-vanished Christoffel symbol. So this minus cotangent of theta. So I add these two terms, okay, because this is a mixed term, okay. I add, this leads to this relation over here, which is 0. So I'll have the three equations, okay, 1, 2, 3, and then on the next lecture I will obtain, okay, the contravariant component of u phi and u theta, u c. Then I use the metric, and then I'll solve the differential equation. See, that's lecture 19A, and you see next lecture 19B, which will continue on this example number 4.